Hello students, welcome back. We completed everything here except for the final section here, Statistics and Technology, which I originally set up as an optional section. But I'm changing my mind. I'm going to require it. Okay, now it's black again. And the kind of technology that you have to know is going to be MS Excel, how to use those, and then, if possible, some Mathematica as well. Here's an example, a very, very famous example by Henry Cavendish, done in 1798. The density of the Earth is known to be about 5.517 grams per cubic centimeters. Henry Cavendish, an English chemist and physicist, was the first scientist to accurately measure the density of the Earth. Here's a data set based upon Higgs experiments conducted on 1798 and published a year later in 1799. And then, from here, you're asked to find out the mean and the standard deviation. Of course, this is a sample standard deviation. And 5-number summary. So you have to get minimum, maximum, median, and also Q1 and Q3 quartiles. Box-Fiskars chart, histogram, and stem and leaf display. Okay, let's do all these with technology. And I'm going to use MS Excel. Alright. And here we go. I already typed up everything here. But this is a little bit cumbersome. Oh, by the way. Alright. Compare these numbers with these. Are they alright? First column versus first row here. Second column, second row. Third column, third row. Do they all fit? Okay, they all fit. And then let's do some computation here. But if you have these three columns, it's not impossible to handle these, but it's rather cumbersome. So let me move it around. Put everything in a single column, and that's going to be much easier. And then let me de-emphasize these in gray. Okay, so these are not really necessary. They are all reproduced down here. Okay, and then what we have to find out, the mean and standard deviation, of course the sample standard deviation, and a 5-number summary. Minimum, and then first quartile, and then median, and then third quartile, and then the maximum. There goes a 5-number summary, and some charts. Okay, ready everyone? Let's go to the notebook, and here's my suggestion. This is the order: cell, function, data, enter. So select the cell where the input goes, where the output goes, and then select the function, and then select the data set, and then OK, enter. That's the order. Here you go. Select the cell. We want mean, and I want that number to go here. Okay, and then select the function. Do you see this sigma here, Greek letter sigma? And then we have a drop-down menu. Click that and find your function. Average, we want the mean. Okay, click it, and the default goes like this. That's not what we want. Select the data set. I'm using my mouse for that. And then click enter. Yeah, there you go. That's the mean. Alright, that was easy. How about standard deviation? Okay, go to the drop-down menu. I don't see standard deviation here, so go to more functions, and then most recently used, and I used it before. But if you're doing it in public computer, or if you haven't done it before, then you're not going to find something here. So you'll have to click this and then go to statistical function. After all, this is a stat class, so everything you need is here, statistical, right here. Select that and go to standard deviation. It's alphabetical, so you have to go down to S. And then you have two standard deviations, standard deviation .p and .s. .s is what? The sample standard deviation. And if you have a list of entire population, then you can do this. But if you have entire population, what's the point of all the sample study? It's impractical. So in this course, overwhelming majority is going to be the sample standard deviation, if not everything. So let's select that. Standard deviation .s, sample standard deviation. Okay, all right. Selected your function, so I have to select the data set. Let's go. Done. Okay. And that is my sample standard deviation. You can use this formula here and do manual computation. This computation, I don't recommend it if you have big data. Not really big data, but even small data with 10 numbers, it's really the tedious thing to do. Elementary but tedious. So don't use handheld calculator, use technology. I don't count handheld calculator technology at this level. Alright, let's go to 5-number summary. Minimum. How do you get that? One way to do it is this way. Select my data here, you see. And then sort it out. Go sort. And then sort from smallest to largest. And we have two options. Expand the selection, then as you sort this one out, all these will follow. So all the answers here and then all these unnecessary stuff will follow, and you're going to get a mess. Sometimes you have to do those when you're dealing with bivariate or multivariate variables, and they have to go together. If they are pairs or triples, then you have to, but in this case, no. So continue with just this one, and you've sorted data. Okay, and then what do you have here? Smallest, the largest. So those are minimum and maximum. And knock off smallest, largest, smallest, largest, smallest, largest, and then merge into the middle. It's gonna be this number. You see, there are 29 numbers, so here from 2 to 30, so middle is 16. But let's pretend that you didn't know how to do the sorting, or you want to explore some other method. Then you can do it this way. Select the cell, function, and data. Cell, function, data. So cell, alright, and then go to function, and identify the minimum. And then that's not what we want. We want this data set. And let's go. See? These match. Let's do it again. Maximum, cell, function, and data. Alright? Cell, function, data. Let's do it again. Median, cell, function. I don't see median here, so let's go to more functions. And then if you're at someplace else, then you can go to statistical, because everything that is necessary is here. And go to median with M. Okay, select. And finally data. Cell, function, data. So got the data. And okay. There you go. That's my median. Cell, function, data. Now how about first quartile, Q1? Okay, one way to handle it is this. Cell, we select it, and then function, more functions, and go to statistical and find quartile. Quartile, where is quartile? PQ. And there are two quartiles. Quartile.exe, excluding the median, and quartile.inc, including the median. Which is the one we want. As far as our textbook is concerned, we have to use .exe. If you use .inc, I'll count it as full credit. So there you go, and then we select the data set, and if you blindly click enter here or click OK, there's gonna be an error like this. Oops, we have a problem. How do you correct? Let's do it over. We did correctly, almost correctly, but not completely. Let's do it over. Quartiles. .exe, and then select the data, and then do not just click OK or click Enter as I just did. You have to complete it. Which quartile? You have to specify it. First quartile, that's what we want. If you click 3, then third quartile. If you click 2, that's second quartile, 2/4. So that's 1/2, that's median. So here goes my first quartile, excluding the median. And then let's do it over. Cell function data. So select the cell, go to my function, that is quartiles.exe as before, and then select the data, and then specify which quartile. It's third quartile. And that's how you can do it. Now, one little comment here. Most of the time, this works okay, but there are some times it does not. That is related to some programming error in MS Excel. It existed for decades, but nobody cares actually. Only math teachers care. Because most of the time, that doesn't cause any trouble, but sometimes it does. So in order to make sure if this is really correct, you can do it manually, but do everything manually is not really fun thing to do, so do it semi-annually. So how do you do that? Sort out the data, alright? And then you want to find out the median of the upper half, right? And let's use MS Excel for the median of this upper half, excluding the median here. So excluding 5.46 is median. This is the upper half, and then you can find the median from here, and that's going to be your Q1. Let's see. Select cell, and then function, and this time your function is going to be median, because you're going to specify the upper half only. And then select only the upper half. Click OK, and in this case, they're both correct. This and that, they're the same. And this too will turn out to be okay, I think. More functions. And then median. Median. And then median of these. Excluding the median here. So, latter half. So this is 3/4 position, and again I got the same number as before. And these two are always correct, but these two sometimes MS Excel does not get it right. It has something to do with the way MS Excel is written. It estimates the percentile first and then convert the quartiles as 25th percentile, and that's how it creates something funky. Sometimes, not always. In this case, it worked out. So if you want to really make sure, and if you want to really make sure everything is right, then you can sort out those data and then compare and do some manual work or semi-manual work like this. Alright, so much for 5-number summaries here, and let's go to some statistical charts. And let's look at box whiskers plot. Okay, alright. With these 5 numbers, it is possible to create a box whiskers chart with paper and pencil and ruler. But can we use technology? Yes, we can. And here is a typical process. We have to select the data set first, and then select chart. And then you have to move it to appropriate place. So previously, you have to select function first. Cell, function, and then data. But for chart, it's the other way around. Data first. Data, chart, and cell. Okay, let's go there. And then data. Here's the data. Select it. And then go to Insert. and then select chart. Then when you chart, so open this lower right hand side corner and then go to all charts. Recommend this chart, I don't see anything here. So all charts, and then do you see box whisker? Yes, down here. And that's the chart you want. Alright, and then you can move it to a plate. You can move it to the cell you want. Let's see, and then okay, this is for Cavendish experiment from 1798 to 1799, and please check. Minimum is 4.88. Does it look right? Maximum is 5.85. Okay, it looks right. And then Q1, Q3, and the median is the line over here. Looks like everything's okay. So for charts, data first, and then insert charts, select, and then move it to appropriate place. Let's have another practice. This time, histogram, but please be warned, histogram is not going to be very good. In order to get really good histogram, you have to have statistical package installed here, but for default MS Excel, it does not produce a good histogram. Nonetheless, here we go. Insert, and then charts, all charts, and then let's look for histogram. Here we go, histogram. And is it possible to do some work? Yeah, okay, histogram. And that's my histogram, but it's just default histogram and it doesn't look very good, to tell the truth. I don't see enough number of rectangles here. This is not very good. We have nearly 30 data sets, 29 data, but I have only 4 rectangles. Not very good. I'd like to have a little bit better, a little bit more refined histogram. But in order to reset everything and customize, you're gonna have to go for you're gonna have to go for some statistical package and install those, and that can be rather cumbersome. If you want to do it right for histogram, you may have to do it manually. Use paper and pencil method with frequency table and all. Here's another example. Let's see. Go to Insert, Chart, All Chart, Histogram, and then let's do this. And this time you're gonna get an OGIF. No, it's not an OGIF, excuse me, it's Pareto diagram. It jumbled up the order, and then from most popular to going down, and then completely disregarded the class intervals. This is terrible. So this does not count as correct answer. Even this is counted as imperfect answer because there aren't enough number of rectangles. So histograms are bad. In order to do it right, you have to get some special packages, but that's additional money. Alright, so much for MS Excel. And if you want further, you can open these cells and study how the Mathematica program works. This is for mean and standard deviation, and these commands are for 5-number summaries and box whisker. And this command is for histogram. And finally, this command is for stem and leaf display.